Hello viewers, today we will study about beta decay. Beta decay is a nuclear process in which a beta particle emits when the nucleus is transformed. There are two types of beta decay. 1. Beta minus decay. 2. Beta plus decay. What is beta minus decay? In beta minus decay, a neutron is changed into proton while it emits a beta minus particle, which is equal to electron and an antineutrino. This can be visualized in the figure below, where a neutron is shown who turns into proton and emits electron with antineutrino. Beta minus particle is in fact an electron, because its mass and charge are equal to the electron. If we write its reaction, then we have neutron, which is shown by arrow decaying into proton plus electron plus antineutrino. We used term beta minus although it is same as electron because in any atom electrons revolve in orbit, but in beta decay electron is created inside nucleus which is then emitted. So to distinguish electrons which was present already in the one which are created we used beta minus term. Where antineutrino are antimatter, who are massless and have no charge. Try to understand beta minus decay with an example of a carbon-14 isotope. Carbon-14 nucleus is unstable. By beta minus decay carbon is changed into nitrogen with emission of antineutrino. Mass number remains the same in beta decay due to interchange of neutron into proton, which does not decrease overall mass number as one decrease in neutron results in respective increase in proton, but this increase alter atomic number.
This happens due to the reason that change of neutron into proton only interchange their individual numbers inside the nucleus. But overall mass number, which is the sum of both, remains the same, but this alter proton numbers whose respective electron numbers should be equal to proton in an atom. To balance this, an emitted electron from the nucleus will add up in orbit around it. How does a neutron decay into proton? This happens due to changes in quarks, which are elementary particles who combine to form protons or neutrons. Neutrons are made up of 3 quarks, 2 of them are down quarks, and 1 is up quark. Whereas proton is also made up of 3 quarks, but 2 of them are up quarks, and 1 is down quark. When a neutron undergoes beta minus decay, one of its down quarks is changed into up quarks. This change of quark results in a change of neutron into proton. This change, in quarks, is due to the presence of weak nuclear force inside the nucleus. Weak nuclear force is one of the 4 fundamental forces that allow particles to change into other particles. By changing their quarks, this change is also called flavor change. Weak nuclear force is responsible for beta decay. Weak nuclear force not only allows quarks to change but during transformation, it also mediates the process by creating negative boson, which is heavy and short-lived. Due to this reason, boson turns into electron and antineutrino, which gives us the whole relation of beta minus decay as neutron decays into proton, plus electron, plus antineutrino. But here, the question that comes to our mind is why we need antineutrinos. During beta decay, not only neutron changes into proton with emission of electron, but they also release excess energy which is carried by antineutrinos, so they conserved energy and momentum during decay process, and that's why they are necessary. The second thing is the presence of leptons. Leptons are fundamental particles who made up electrons and neutrinos. When the electron is created inside beta decay, a lepton number +1 of the electron is also created, which can be balanced by the lepton number of antineutrino, which is -1. So to balance the reaction and avoid any nuclear laws violation, their leptons number cancels with each other. If antineutrinos are not created along electron in beta decay, the reaction cannot be conserved. It is not always a neutron transformed into proton. Sometime, a proton turns into a neutron with the emission of a positron and neutrino. This phenomenon is called beta decay. A relation is shown with arrow where a proton turns into neutron, plus positron, plus neutrino. Positron is a positive electron whereas neutrino is its antiparticle. Beta decay occurs due to weak nuclear force. This force, same as in beta decay, allows quarks to change, but here up, quark inside proton is changed into down quark and turns proton into neutron. In beta decay, a heavy, short-lived boson plus is emitted, which turns into positron and neutrino to balance lepton numbers and conservation of momentum and energy, same as in beta decay. But here, things slightly change. Proton decays into neutron, plus boson emitted instead of negative boson, which is then turns into positron and neutrino opposite to the negative boson, but role remains same. Here in beta decay lepton of positron is +1 which is balanced by lepton of neutron which is -1. Let's take an example of a carbon-11 isotope, which turns into boron by beta decay, but the mass number remains the same because proton and neutron interchange, so the overall mass number is not disturbed. But due to the change of proton into neutron, the number of protons decreases by 1. So, for an atom, the number of electrons and protons should be the same. To get rid of this problem, a positron is emitted into orbit, which cancels one electron in orbit, and we have a stable atom with no violation of nuclear law. Beta particles are emitted in beta decay. They can be electron or positron depending upon the type of beta decay that happens inside the nucleus. Beta decay is due to nuclear force. Beta- has two key points: change of quarks form up to down and creation of negative boson, which then turns into electron and antineutrino. Whereas in beta plus things happens opposite by change of quarks for down to up, creation of positive boson which then turns into positron and neutron. Beta particles are either positive or negative. That's why they have moderate ionizing power but less than alpha particles due to less charge on them. Moderate ionizing power due to charge on them. Whereas they have also moderate penetrative power greater than alpha decay due to their small size and fast speed, which allows them to pass through paper or even skin. As beta particles are charged particles, so they can be deflected by electric or magnetic field. Due to their light mass, they are deflected more as compared to alpha particles, which are heavy. Here we have beta particles which move towards positive and negative plates of uniform electric fields, we see that positron deflected towards negative plate whereas electron deflected towards positive plate due to electrostatic attraction. Beta decay plays an important role in nature, especially beta plus. Due to beta plus decay, a proton chain reaction is initiated inside Sun, which powers up Sun and most of the other stars. See, we can say that beta decay is behind light of Sun and stars. In next lecture we will study gamma decay.